Spice Math. That's right. You add it up, multiply it, man. Spice Math. Okay. A couple things we're gonna learn today. Spice Math. All right. Take some time, educate yourself. Spice Math. That's right. You won't believe it's just math. Come on.
Hi, I'm Ruth Doughton.
Hi, I'm Aaron Williams.
Hi, I'm Brandon Alexander.
Hi, I'm Kelvin Doughton.
Hello, I'm Lyndon Sincere.
We are your Spice Math tutors.
You won't believe it's just math. Just math.
Hello everyone, welcome back to Spice Math. In today's lesson we'll be looking at decimals, and the tools you would need would be a pen and a pencil, a notebook and a calculator. The objectives for today, that is at the end of the lesson, you should be able to define what is a decimal. You should be able to explain the origin of the decimal system. You should also be able to explain the conflict between base 10 and base 12 and base 60. And lastly, you should be able to explain the positional characteristics of the decimal number system. Now, many years ago, different cultures around the world realized that they had to count stuff. And in order to count, as life got more complex, they realized that they needed bigger and bigger numbers. So, just around 3400 BC, the Mesopotamians came up with what is called a hexadecimal system based on the number 60. Interestingly, today we still use some of those characteristics. 60 seconds equals 1 minute, 60 minutes equals 1 hour. 360 degrees gives us the complete angle in a circle. As the years passed and civilizations grew and life became more complex, the decimal number system was developed, and many people didn't realize that the information was right there in their very hands. 10 fingers, 10 toes. So our decimal system is based on the number 10. And today we want to look at what is a decimal system. The word decimal actually means, as I said before, based on 10. Decimal, based on 10. It's also a system that characterizes the position of the digits in every number. So for example, the number 317, the 3, the 1 and the 7 each has different values because they're in different positions in the number. The 7 is what we usually count positions from the right. So we're going to start with the 7. The 7 is considered the first number, and its value is based on what is commonly known as units, or 10 to the power of 0. The second number, if you follow the trend going to the left, the second number, 1, is commonly known as tens, or base 10 to the power of 1. And I'm sure by now you can guess what the third number would be. 3 would have its value from 10 to the power of 2, commonly known as hundreds. Of course, as the numbers get bigger, the power of 10 increases as you go further to the left. So for example, this number would of course be bigger, and each digit in the number would have a value based on its position. The challenging part is how do you take these numbers and actually find out the real value. It's based on addition. So the number that we know as 2,758 is actually 8 times 10 to the power of 0 plus 5 times 10 to the power of 1 plus 7 times 10 to the power of 2 plus, we're going to go a little at a little angle there, 2 times 10 to the power of 3. Hence, 2,758. How then would you be able to obtain the value of, let's say, a bigger number? We can use the same strategy. We can use the same principle, the powers of 10 starting from the right, and we can expand any number we want. Okay, so using the powers of 10, we can expand every number and get its actual value by adding up the sums as we go along. The decimal system also deals with fractions. And what they use to separate a whole number from a fraction is the decimal point. Now that's a dot that separates two numbers in the center of the numbers. So for example, 4.8 is a decimal number with a whole part, the one on the left, and a fraction, the one on the right of the decimal point. Again, the fractions follow a similar principle using powers of 10. But because it's a fraction, the powers are going to be negative. So 4.8, if we were to expand it, would be, since 8 occupies the first place, right to the right of the decimal point, the first place would be 10 to the power of negative 1. So the number 8 in this number is actually 8 times 10 to the power of negative 1, which is just another way of saying 8 times 1/10. And the number 4 would be 4 times 10 to the 0. Now, decimal fractions are usually very, very difficult and pose quite a challenge for some people. But if you understand the principles of the powers of 10 on which they're built, you can work out any decimal fraction. So don't be afraid of the numbers. So, what then would be 6.78? How would you expand this number? It includes a decimal. It's a decimal number, but it's made up of a whole number and a fraction, with the decimal point defining the difference between the two. So what would be the value of the 8? Based on its position to the right of the decimal point, it's going to be 8 times 10 to what power? 10 to the power of negative 2, or 8 times 1/100. The 7 would be in the first position to the right of the decimal point. So that would be 7 times 10 to the power of -1, or 7/10. And the 6 is on the left side of the decimal point, so that would be 10 to the power of 0. 6 times 10 to the power of 0. Using these expansions, we can convert decimal numbers into an expanded form, and we could take expansions and convert them back to decimal numbers. In today's lesson, you would have learned what is a decimal. You would have understood the difference between base 10 and base 60, as I mentioned earlier, and the fact that base 10 came from 10 fingers. And you can see in real life today how we have been able to integrate base 60 when we count in time with base 10 when we count other ordinary numbers and things. Thank you very much. We have an activity for you that will be coming up on screen. We'd like you to attempt them.
Spice Math. Okay. A couple things we're gonna learn today. Spice Math. All right. Take some time, educate yourself. Spice Math.